Welcome to This Explainer. Today, we're going to unpack something truly wild. How a country famous for building absolutely everything is now engineering a trillion-dollar system to break it all back down. We're talking about a massive industrial shift that is completely redefining how we look at the things we throw away every single day.
Right off the bat, let's just let this staggering number sink in for a second. 4.4 billion tons. That is the amount of solid waste generated every single year in China. To put that kind of sheer volume into perspective, we're looking at nearly 3 times the output of the United States. It's so massive that simply finding empty land to bury it in, well, that's just no longer a viable option. Cities were literally running out of space, with mega landfills hitting their 50-year capacities a full 25 years ahead of schedule.
But this creates an incredible juxtaposition. Think about this. The richest gold mine on Earth isn't actually underground anymore. It's probably sitting right there in your desk drawer, full of old tangled cords and dead electronics. If you pull a ton of rock from a traditional gold mine, you might yield just a few grams of precious metal. But a ton of discarded smartphones, circuit boards, and laptops, that yields exponentially more. It's this wild concept known as urban mining, and it completely flips the script on what we consider to be a natural resource.
So here's a quick look at our roadmap for today. We'll be walking through the trillion-dollar trash machine, urban mining and black mass, the clean energy paradox, building and breaking cities, sorting the unsortable, and finally, powering the grid with trash.
Section 1. The trillion-dollar trash machine. From green myth to industrial reality.
Look, we really need to reframe how we think about this right now. We have to stop looking at the scale of recycling as just some feel-good green initiative. We need to start seeing it for what it actually is, a ruthless, highly efficient industrial machine. For a country producing nearly 30% of all global manufacturing output, raw materials are the absolute lifeblood of the economy. So, when China banned the import of foreign solid waste back in 2018, it forced the creation of a massive domestic collection system. They aren't dismantling millions of cars and phones just to be eco-friendly. They're doing it because the materials inside them are worth an absolute fortune, and they desperately need them to feed their manufacturing sector.
Section 2. Urban mining and black mass, extracting treasure from tech.
Now, whether it's an end-of-life vehicle or a tiny circuit board, getting to that value requires some incredibly precise, labor-intensive steps. You can't just toss an old electric vehicle battery into a crusher. If you crush a partially charged lithium battery, you're going to get a massive, uncontainable fire. So step 1 has to be safely extracting those residual charges and hazardous fluids. After that, workers carefully, manually dismantle the high-value components. It's only after the dangerous and precious parts are separated out that the heavy industrial shredding can actually begin, tearing through the casings and wires to sort out base metals. But the ultimate prize? That happens in step 4.
The true prize here is something called black mass. It's this dark, intensely valuable powder created from those shredded EV batteries, and it is packed with concentrated lithium, nickel, cobalt, and manganese. Right now, China is handling between 70% and 90% of the entire planet's battery recycling and refining. And here is a fascinating geopolitical twist for you. While Europe was tightening regulations and classifying this black mass as hazardous waste, China went the other way. They officially implemented a new standard for July 2025 to reclassify it as a tradable product. They essentially threw open their doors to import the world's most valuable battery powder straight into their own factories.
Section 3. The clean energy paradox. The solar panel problem.
If you were to just weigh an old solar panel, you'd find it's mostly heavy glass and a little bit of aluminum. But focusing on weight is totally the wrong way to look at this. If we shift gears and look at the economic value, the silver inside those silicon cells, which makes up a tiny, nearly invisible fraction of the panel's physical weight, actually holds over 60% of its total economic value. It completely flips our understanding of what makes this waste so important.
But here's the catch, and it highlights a massive, unseen engineering hurdle. For 30 years, really clever engineers worked tirelessly to make sure rain, hail, and extreme UV rays could never, ever penetrate that panel. They are heavily laminated and glued together like crazy. Now, recyclers are tasked with undoing all of that. Just to get to that tiny sliver of silver, you have to melt through decades-old adhesives and polymers or use super expensive chemicals. It costs so much energy and money that the silver is almost hopelessly trapped inside. With millions of tons of old panels expected by 2030, this is shaping up to be an incredibly complex paradox.
Moving on to Section 4. Building and breaking cities, the heavyweight champion of waste.
Let's trace the life cycle of a modern city for a moment.
It all starts with microscopic quartz and blasted limestone, fired in massive kilns at over 2,700 degrees Fahrenheit, just to create cement. That builds the sprawling concrete jungles we live in. But fast forward 50 years or so, and you inevitably hit a colossal demolition phase. When a skyscraper comes down, it doesn't just disappear. It leaves behind a chaotic mountain of concrete, rebar, glass, and drywall.
And this leads us to a really fascinating economic contrast. In the year 2020 alone, China produced about 2.6 billion tons of construction rubble. But unlike smartphones or those EV batteries we talked about, China only recycles about 12% of this construction waste. Why the huge gap? Well, the technology to crush rock certainly isn't difficult. The problem is the money. Crushing concrete into aggregate gravel simply doesn't pay very well. It is very often cheaper to just dump it in a landfill than to spend the money sorting through chaotic, mixed demolition rubble to make low-value road foundations.
Section 5. Sorting the unsortable. Textiles, plastics, and the power of law.
Check the tag on the shirt you're wearing right now. If it says something like 60% cotton, 35% polyester, and 5% elastane, well, congratulations, you're wearing an absolute recycling nightmare. Standard mechanical shredding just ruins those blended fibers. But pure synthetic fibers, like 100% polyester, are a different story. They can undergo chemical recycling. These facilities can essentially vaporize the polyester right down to its chemical base, a substance called DMT, at 99.9% purity and rebuild it into brand new fibers. Purity is absolutely the key to making this magic work.
Now, food waste is a whole other beast because it's wet, it's heavy, and it completely ruins dry recyclables like paper and cardboard. But the most powerful tool to fix this wasn't some state-of-the-art chemical plant. It was actually a strict law passed in Shanghai in July 2019. It mandated household sorting into 4 strict categories and handed out hefty fines for breaking the rules. Practically overnight, the daily capture of wet organic waste skyrocketed from 4,000 tons to an astonishing 10,000 tons.
And again, purity is literally the name of the game here. Because citizens were sorting their waste so strictly, the food waste arrived at 99.5% purity. You can't put plastic bags into an anaerobic digester or the whole system breaks. But with pure, separated organic waste, these facilities can efficiently use bacteria to literally eat the food and convert it into biogas. That gas is then used to generate electricity and heat. So pulling the wet food out saved all those dry recyclables while simultaneously creating a brand new energy source.
Section 6. Powering grid with trash. The final incineration. Okay, so what happens to the stuff that just can't be saved? Now we enter the waste-to-energy plants. It's a highly automated marvel, honestly. The waste arrives and gets dropped into these massive underground bunkers where giant automated grab cranes continuously mix it all up to ensure it burns evenly. Next, it's pushed into massive incinerators burning anywhere from 850 to 1100 degrees Celsius. This extreme heat safely destroys hazardous compounds and creates high-pressure steam. That steam then spins giant turbines, generating billions of kilowatt-hours of electricity. It reduces the physical volume of the trash by up to 90%, all while keeping the lights on in millions of homes.
This represents a totally massive shift in how a nation handles its waste output. Seriously, forget the old cliche of overflowing, stinking landfills. That's incredibly outdated now. Today, an amazing 78% of China's urban household waste goes straight into these high-tech incinerators. Only 13% ends up in sanitary landfills. The ovens have officially taken over the landscape.
The sheer scale of this is just breathtaking. By the end of 2024, they were operating over 1,100 of these plants. And here is where it all seamlessly connects back together. Remember those strict sorting laws in Shanghai? Because the wet food waste is pulled out beforehand, the remaining dry trash acts almost like a high-grade fuel. It burns hotter, it burns much cleaner, and it generates electricity far more efficiently. These plants actually provided up to 7% of the nation's household electricity in 2023. It just proves how deeply intertwined this entire industrial metabolism really is.
So I'm going to leave you with this to chew on. Think about the devices and everyday items sitting in your home right now. Between the heavily glued solar panels on the roof, the chemically blended fibers in your shirts, the heavy rubble of our concrete buildings, and the volatile, hazardous chemistry of old electric vehicle batteries, which one of these presents the ultimate engineering paradox for our future? Which one will define the next century of our industrial survival? Keep that in mind the next time you toss something in the bin. Thanks for joining me on this explainer, and I'll catch you on the next one.